we're going to move on to our next topic now, which is a presentation from the SOCOTEC Fire Engineering team. I'll let them introduce themselves. So I'll hand over to Hamza.
Thank you. Thank you, everyone, for joining here today, where we explore the topic of fire safety in heritage buildings. My name is Hamza Khan, and okay, probably I'll start with my introduction first. My name is Hamza Khan, and I'm working as a fire safety consultant at SOCOTEC Manchester office. Previously, I have been involved in BRE in fire research consultancy and a research engineer at Aalto University in Finland. Academically, I have a background in structural and fire safety engineering. So today's presentation is about fire safety in heritage buildings, the importance of these buildings in our social economic environment, the legislative requirements of the government, UK, and how we meet those legislative requirements based on the recommendations of the fire safety guidance. And then I will present some case studies where our fire engineering team faced some challenges and how we came up with unconventional methods of achieving the objectives of fire safety, and what are the usual challenges in implementation of the fire strategy in a real life building, and the conclusion, key takeaways from this presentation. The heritage buildings are not just buildings made up of brick or stones, but they carry an immense cultural and heritage value because of the history and throughout the history they have been through. So especially in the UK, these buildings are not just only museums or castles, but they are playing an immense role in the country's national infrastructure, consisting of universities, theatre buildings, council buildings, and everything else. But we have seen in the history that these buildings are vulnerable to fire more as compared to the new build structures. And for example, the last month fire in Somerset House in London, Burson building fire earlier this year, and the Notre Dame fire we are all aware about. But there are some fires that go unnoticed in these buildings. So the definition of a heritage building is that it is a cultural or historical structure of immense architectural or cultural value, which is legally protected under the Section 1 of Planning Act 1990. And the National Heritage List for England mentions that there are more than 370,000 entries for listed buildings categorized into three categories based on their importance: exceptional interest, special interest, and more than special interest. All these structures have unique characteristics such as the age, construction, and the materials they are made up of, and the architectural style, which is not always easy to comply with the modern fire safety methods of compartmentation, the limitations on the means of access, and the limitations on the combustibility of materials. So we have talked about, a lot about the new and a lot of legislations and regulations on fire safety. But I will just talk about the primary ones, which are the Building Act 1984 and the secondary legislation, which translate into the building regulations. And in order to meet the requirements of these regulations, we take guidance from the prescriptive standards, such as British standards or approved document. However, these guidance documents do get updated once or twice in a decade. So there are some special interest groups, such as in the Institution of Fire Engineers, who come up with more up-to-date guidance on these structures. The fire safety in heritage building is of critical importance because the design of these buildings has some inherent risks, such as the building fabric could be made up of combustible materials, the presence of chimneys, or the wooden panelings or textiles within these structures, which are not easy to remove. So we will lose the definition of, we will lose the compliance with the definition of sustainability, which is that we have to pass on these structures to our future generation as we have received it from our ancestors. There could be electrical systems from the previous century which could be outdated and extensive cavities, presenting a risk of fire through these structures. The existing design may not always comply with the compartmentation and the requirements for the structural elements on these systems. The lack of ventilation system. They do have ventilation system in the older and historical buildings, but not as like we propose smoke ventilation system in the newer builds. The limitations on travel distances and the access for the firefighters to go into the building and fight fire in an event it happens. When we look at the fire strategy of these buildings in our company, we always try to approach it comprehensively through the similar methods like we do it in a new build, for example, defining the occupancy of the building and how to limit the use of different spaces. We do have recommendations for the active and passive fire safety measures, which could be the fire detection and alarm system in order to alert people who are in the building, and the ventilation, the fire separation of different areas, the fire doors, which are of critical importance, the installation of automatic fire suppression systems, which is easier in the new build, but not in the existing ones. So not always practical to achieve. And if it's a communal building, then there are some measures for the security and housekeeping. The critical thing about means of escape is that all the occupants in the building need to feel safe in an event of fire, and they can make an escape without being getting stuck into the building. So we do mention the travel distances and exits capacity as we do in the new structures, but there are some limitations. So we'll talk about them later. With the introduction of London Plan Policy 2021, there is a criteria for inclusive design, which mentions about that all the people with reduced mobility should be able to evacuate without feeling differentiated from the other occupants of the building. So that is something to look for in these structures. The Access for All scheme in heritage railway structures, this is something to look into and implement in the fire strategy. So we have a limitation on the internal fire spread of the limitation on the internal linings of the building, because the delicate structures and the materials of the building may not be always easy to replace, because they carry a cultural and heritage value. Similarly, the structural elements like columns or beams might have architectural features that are not easy to replace. The limitations on external fire spread, we have often found that these buildings are located in the congested urban environment, and there are limitations on the space separation between different buildings, which the modern fire safety guidance does mention and put some restrictions, but in the heritage buildings, it's not always easy to achieve. So for example, the use of water for fighting a fire within these buildings is not always practical, because it will damage the internal fabric of the building and may not always be helpful in the firefighting methods. So I will start with the first case study where SOCOTEC Fire Engineering team worked on the Theatre Royal at Drury Lane in London. It is a Grade 1 listed theatre building, um, operational since 1812, 6 stories building with a basement, and it has a back of house office accommodation, which the client wanted to convert it um, into a into a restaurant space consisting which can accommodate around 300 to 400 occupants. So the total occupancy of the auditorium is itself about 2,000 people, and adding 300 more people into the back of the building is kind of a fire safety challenge um, to to counter for. And there was some challenges, unique challenges related with the fire detection, because the conventional fire detection was only based on the smoke detection, not always possible if there is some sort of a performance going on the stage which has smoke itself. Heat detection might not always be possible because if there are some fireworks on the stage, um, the width of the doors which were existing um, was not enough to accommodate all the occupants in a building like this. There were extended travel distances, and the 3 stairs which were providing um, um, access to all the upper galleries for the occupants um, were very close together and not lobby protected from the other areas. So we had to discount these and then calculate the overall occupancy of the building. Now the fire doors over the time, they were distorted, um, not fit for their function, and no firefighting shafts or smoke ventilation in the basement. Now, a very similar structure, a theater building, it's called Iroquois Theater, was burned down in US in around 1903, which had the occupancy of almost 2,000 occupants. And during the fire, almost 600 people died in that fire. So just not to repeat the same outcome of the history, we had to implement unique fire safety methods. So our key recommendation was, first of all, to upgrade the fire detection system, introduce a multi-criteria detection, which not only looks at the smoke or heat, but also on the flame and the growth of fire within a specific period of time. The extended travel distances were justified based on the increased height of the building. The discounting of stairs could not be made better, but we did not make it worse than the existing condition. A lobby protection was recommended and achieved in the back of house and auditorium areas. Refuge points were introduced. And now the existing structural fire resistance was unknown because of lack of design documentation on this structure. But according to the new guidance requirement, the structure should be able to achieve 60 minutes of fire rating in the event of fire. So the basement without smoke ventilation was proposed to provide more compartmentation so that the fire remains within the basement and not spreads throughout the structure. The second case study is about Lancaster Gate in London, which was proposed to be converted from a hotel use into a residential development. So now the number of dwellings in this building were going to be reduced, and the Section 5 of the building regulation mentions that even with reducing the number of flats or dwellings, it comes into the material change of use definition, and the whole building needs to achieve the best possible or highest possible standard of fire safety, as also mentioned in London Plan Policy 2021. So the topmost story was 21 meter. it's more than 11 meters, so we had to introduce sprinklers in the building. The basement was reserved for the plant rooms, cycle stores, which were not lobby protected in this case and had to be separated from the stairs, so that in an event of a fire, which could be due to negligence or maybe due to arson, the smoke does not go into the stairs and leave all the building occupants into their apartments. The main objective was to also keep the facade of the building untouched. So that was the limitation. The key fire safety challenges, as mentioned, the inclusive design, the presence no evacuation lift. We had to introduce an evacuation lift within the building, and the automatic fire detection system was upgraded so that all the occupants can stay within their apartment in an event of fire. The introduction of lobby between the stair core and the cycle store was done in this project. The third and last case study is about 84 Moorgate in London. It's called Electro House, and the proposal was to convert this building from a university accommodation into an office accommodation. It had an unconventional layout, a very massive building with 2 basement stories, and the height of the occupied floor was 26 meters almost. There were excess travel distances, and the stairs were all serving the basement, which would not be possible in a new built structure. However, this was like a conventional or a heritage structure, so we had to adopt and not make the existing conditions worse. No firefighting shafts or dry risers were present, but there was a proposal for the introduction of an openable vent within the central stair, so that in an event of fire, the smoke goes into the stair. It can go out of the building through the window or vents. Yeah, so these are the challenges which are to the fire safety and fire strategy development, but there are some challenges during the implementation of these recommendations. For example, we have 2 objectives, 2 conflicting objectives here. First, we want to preserve the building and its existing features. And the second objective on the other end is that we want to make sure that everyone who is in the building is safe and can get out in an event of fire. So we have to go for a balanced approach. There's also a conflicting interest between the funding and the resources. If an existing building is taking so much resources and economical backing that and the money for regular maintenance, then wouldn't it be more useful or helpful to build a new structure with state-of-the-art fire safety systems? And then there are some construction complexities with the methods of construction, the damage during construction, and the specific skill set required to be able to restore these buildings, which is, of course, not always the cheapest possible option. However, there are some future directions and innovations, the emerging technologies that could be helpful in improving the fire safety of these buildings. For example, comprehensive building information models with additional layers of details for the fire engineers to work on and collaborate with different departments so that the overall fire safety could be improved. The real-time monitoring of the information present within the building and the feeding of this into the online systems so that we can look at the data retrospectively to find out what are the factors that are contributing to the fire safety of these buildings, and maybe further research going on around thermal imaging for the location and identification of hotspots within the building where the fire load is, and how can we fight the fire in case it happens, not just with water, but with some additional or maybe some innovative methods of expressing it. Could be some invisible coatings on the existing features so that um, they are not very combustible and not very at high risk of catching a fire. And of course, there is a need for collaboration and new policies that need to be developed for the safety of these buildings. And there is a need for the community involvement and education among all stakeholders to get the fire safety objectives. So the conclusion and key takeaways from this presentation is that we have to go for a balanced approach between the preservation and fire safety, because these are not just structures, they are carrying immense cultural and heritage value. We have to comply with the regulatory framework, the legal requirements in these structures, and to ensure that the public which is using this building is safe. The fire safety challenges are comprehensive, sensitive, and our objective is to not make them worse than existing and pass these structures to our future generation as we have received it from our past. Social economic challenges related to the funding and revenue, the complexity of construction and the collaboration, the need for all stakeholders to sit together and find a solution to meet the objectives of fire safety in these buildings. The disruption of services, what are the public interest, whether to spend so much money on restoration of these structures. And of course, there is a requirement for responsibility and competency. And then this can be sorted out with the help of innovation and emerging technologies in the future. So that's all for my presentation. Thank you so much. I can pass on to my colleague Tabia and Andrea. They are from fire engineering team in SOCOTEC London office. Yeah.
Yes, hi, welcome to the second presentation focusing on fire. My name is Tabea Ur, I'm a principal fire engineer at SOCOTEC. Got a promotion, yay! And I'm here with my colleague Andrea Galeano.
Hello, my name is Andrea Galeano. I'm a fire engineer working at SOCOTEC for the last 2 years. And yeah, happy to be here.
Yes, and following on from Hamza's presentation now about more of a design aspect about fire safety, we're now going to focus a bit more on what it means in a more temporary case of when we do construction, how can we safeguard our buildings during construction? And because obviously I know that this conference today is very much focused on renewable materials, renewable construction materials. We're going to focus specifically on the construction of CLT structures as well as timber structures. So here's just a quick table of content. We're going to talk a little bit about an introduction of what it means when we talk about fire safety during construction, where we are currently with modern research and where we as a fire industry want to head towards when we look at CLT or timber structures. We're going to talk about some of the typical fire risk you can encounter on your construction sites, talking about a bit of background, and then we have one case study towards the end to discuss. So looking at the introduction, I hope everyone now understands from Hamza's presentation with fire safety engineering specifically, we're looking at the prevention, the control, and the management of fires. And that means specifically the safeguarding of life, but also we're looking at property protection and then business continuity and the impact of all of that. And then obviously during the construction site, we're focusing specifically on that maybe 1, 2, but also maybe 10-year gap for when the building is being developed. Now, obviously, we heard that before. The current construction industry is a very high percentage of the pollution that is currently generated. I found a number of about 37%. You guys might know better than me if that's roughly correct, but let's go with about a third of the global emission originates from construction and the build industry. So looking at CLT and timber construction as a renewable construction material is a very good way that we as an industry want to go to. And especially when you combine these with modular structures or prefabrication, you can very efficiently start to build your buildings. But looking at it from a fire safety point of view, your timber, your CLT is a combustible material. It's going to participate in your fire event and make that worse. We need to comply with the specifications that Hamza explained just now. We're looking at linings, we're looking at the structural fire resistance of that timber, which will burn eventually, and its combustibility. And also picking up from an earlier presentation about the Grenfell Tower fire, we're still picking this up, the results and the impacts of this fire where 72 people died. We're still working on this. And one of the biggest impacts the inquiry had on our industry was the removal of all combustible materials from the facade of residential buildings over 18 meters. It's a huge impact for us because now when we want to build with CLT and timber and we want to move there, this is a big limitation for us in England and not something we can move or overcome at the moment, given the impact that Grenfell had on us. So we as an industry are more now heading towards more low and mid-rise non-residential buildings where those limitations are not in place, and now looking to use structural timber and CLT in these sort of buildings. In order to support these type of things, there's been a lot of research done recently. So here, for example, we see a recent fire test for a large compartment that you might find in typical office buildings of 380 square meters. The research test was specifically called Code Red, and they were looking at the partial protection of CLT and your CLT ceilings and structures. So, oh gosh. Here we can see our column that's enclosed. We see a beam that is enclosed. And then you can barely see up here that some of the ceiling is unexposed. They also looked at water mist, so a water mist suppression system that would create like a mist, a voluminous mist throughout the building to then suppress the fire. And what they found in this fire test specifically was that there's a lot of radiation happening between your combustible materials, so your chairs, your tables, etc., and then your CLT ceilings, kind of radiating and propagating that fire spread throughout your compartment, especially when you have very large compartments. But they also found that even just a partial encapsulation with protective materials such as a plasterboard, a cement board, or these type of things can significantly stop the spread of fire. And water mist systems or other suppression systems as well helps with cooling, helps with extinguishing, and these type of extracts. So the problem now that we face on our construction sites is partial encapsulation, full encapsulation, water mist systems. We're just about to build them. They're not here yet. So in most cases, we're looking at unprotected timber. We're not here yet. And some of those risks will now be explained by Andrea.
Thank you. Okay, so first of all, we're going to speak about fire risk on construction sites. So regardless of the building height, we need to always have on site one construction fire safety strategy. But of course, the fire safety measures that we need to consider when preparing the fire safety strategy will depend on the building height, the building complexity, and all the design fire risk that we have on site, like specific to that project. And as Tabia was saying before, because the building is just like being constructed, we don't have any of the passive or active fire safety measures that the final design will have. So we will not have compartment walls achieving any sort of fire rating. We will not have a suppression system. And of course, this represents that during the construction stage, our building will be in its period of maximum vulnerability. So going just like Fire 101, the basics. For a fire to start, we need 4 elements. First of all, we need the oxygen, so that is going to sustain, support the combustion. We need as well the fuel sources, we need the heat sources, and we need the the chemical chain reaction for to sustain the combustion process. So when we start thinking about fuel sources on a construction site, we have, first of all, the structure. If we're speaking about CLT or timber frame structures, temporary gas appliances, flammable substances, combustible materials, waste. And when we speak about heat sources, we typically have hot works, cigarettes and lighters because people is smoking on site, heating installations, electrical faults that due to lack of maintenance or misuse can lead to fires. And of course, cooking facilities, because typically construction sites, they have a canteen provided for the employees. And in these facilities, it can end up in an oil fire. So in the previous slide, we saw typical heat sources, fuel sources that we have on site, on a construction site. For us, that's identifying the risk. Those are our risks that we have on site. So we need to, first of all, try to eliminate those risks. If we can't, then we need to move to reduce the risk. And of course, then try to control it. So starting with the first one, the structure. If it's a timber frame, CLT, then this, of course, is going to increase the fire risk. And this is not something that we can eliminate on a construction, because this is actually something that was defined in the design, right? So we need to try to find an alternative to reduce the deliberate or the accidental fires on site. And some of the measures that can be considered in order to do this is actually provide non-combustible materials or non-combustible construction materials on the lower levels. And then in all the upper levels, we can provide timber. Typically also the main cores where you find the protected stairs, they are also enclosed in non-combustible construction. Then in regards with storage of combustible materials or waste, so the first column will always be related with identifying the risk. So of course we need to assess the site for all the areas where the combustible materials is stored. And then when it's related to waste, this is something that can be managed on a daily basis. This is something that can be removed at the end of every shift. So this is one of the measures in order to eliminate the fire risk of having a lot of waste accumulating throughout the day on site. And then in regards with the storage, we try to, this is something for the site manager to control in order to reduce or minimize the amount of combustible materials or the amount of combustible materials, construction materials that are going to be stored at the same time. Then in order to reduce that, in order to reduce this risk, one of the measures is actually to store any sort of combustible material in uncombustible containers or designated storage areas or in areas that are enclosed in at least 30 minutes fire rating, provide heat detection system as well. Of course, trying to keep a separation in between the areas where we have storage or areas where we have waste, separated a specific amount of meters from the site or any other ignition source. And this is something that, of course, needs to be strictly implemented and ensure that all the materials that are stored are kept stored in accordance with the construction fire safety strategy. One of the highest cost of fires is actually hot works, and it tends to happen in construction, new buildings, refurbished buildings, any type of building. So that's why it's always important to assess, and we need to know the contractor. This is a risk for the contractor to manage. It's really important for them to know that this is a really, really, really high fire risk. So trying to eliminate that, it's removing all hot works from site. But of course, we know this is not really easy to achieve on a daily basis. So sometimes we can say, okay, you can substitute these hot works with safer alternative. You have mechanical fastening, you have cold cutting techniques. If this is not feasible, of course, then you will need to do the hot works in a designated area, following some control measures, such as minimum 3 hours fire watch or the use of thermal cameras. Then another fire risk is smoking. So again, for the contractor to manage, assess the potential ignition source. We can implement on site a non-smoking policy across the construction site. And this can work on a red card system. So it's when, for example, for the football players, if they commit a fault, they will have the red card, they will need to leave the field. So for a construction worker, you will have a red card, you're going to be removed from site during that day. And if it's something repetitive, then eventually you will get fired. People will always be you will always find someone that is going to smoke. So typically on construction sites, there is an area that is assigned as a smoking area that is properly designated, is properly has properly signage. It is away from all the ignition sources, flammable materials, and there is always a metal waste bin for appropriate disposal of the cigarette butt. This is really important for the management to control and to provide training to all the personnel, because it's really important for them to know that this, of course, can occasionate a fire risk.
And now I'm going to talk about 2 more risks that might be present on your construction site, which are slightly more different. First one is the typical building features, and specifically atria, because obviously with the large space that you have in your building, fire and smoke can easily propagate throughout your construction site unhindered, essentially. So what we do for these type of buildings is we're going to place compartmentation, so fire resisting structure, in strategic locations to prevent that, to limit the space and the area where fire and smoke can spread. And reduction measures, for example, are a clever look at the construction program and the scheduling. Implementing certain features, for example, your compartmentation lines at key dates in order to reduce the impact a fire could have that spreads throughout a large common space. As well as we need to have a look at the prevention of external fire spread. With large spaces, a lot of heat would be radiating to adjacent buildings, and obviously we don't want to set our neighbors on fire. So we need to have a look at that as well and provide areas where there are very limited amounts of combustible materials. Where our structure is combustible due to the CLT or timber, we need to be especially careful and maybe even consider additional safeguarding features, like a temporary protection measures, temporary plasterboard or something like that. And again, as always, it's for the contractor to enforce these kind of restrictions explicitly on site, make sure that they're adhered to, as well as always, communication and training for all of the personnels. A second feature which might be of interest to our colleague from earlier, who was like to talk about dust. We also like to talk about dust on construction sites because it's a very common occurrence, and as much as you don't think it relates to fire, it kind of does, because it's fine particles that can propagate fire growth, but also there are some minor explosion risks as well. What we tend to recommend as the fire engineer on construction projects is to say, well, just extract it, please, avoid having dusty areas, keep it clean. or do it outside, because when you don't do it, you're actually going to set up your smoke detectors. The smoke detectors we put in to safeguard the site are set off by your dust. So instead of smoke detectors, we tend to place heat detectors on site to avoid these type of things and to avoid false alarms, because once people get used to having false alarms, they will either cover up the detectors or just ignore it. And once there is an actual fire event, that's not very good for us. Yes, so make sure that procedures are adhered to and work areas kept clean. And again, don't cover up your detectors, please. So now looking at the technical background, is back to Andrea.
Okay, so how do we know which measures do we need to consider in a construction fire safety strategy? There are three main documents that we need to follow. First of all, we have the HSG 168. It was developed by the Health and Safety Executive, and it is enforced by them as well. This is a mandatory document enforced also by UK law, and most of the document, it gives us a little bit of information about like the fire risk assessment, everything that we discussed previously, fire risk, how to identify, how to control, how to eliminate, the measures that we need to consider, and a little bit more of general information. And then we have the joint code of practice that we call JCOP. This is opposite to the other guidance document. This one is a voluntary code. This was developed by the Fire Protection Association in conjunction with the construction group. And this is mainly going to give us some fire safety measures that we need to consider on site in order to comply with the requirements of the insurance companies. So that's why when we work with this document and the HSG, kind of like we complement our work. So this mainly we find information about the fire safety measures, passive fire safety measures, such as the provision of fire doors, compartmentation, location of the storage, protected coverage, the location of alarm and detection systems, active fire safety measures, the location of the fire points, fire extinguishers, everything that we need to consider for the means of egress, such as the fire escape plan, the number of exits that we need to consider, the location of them, the location of the fire points, as well regarding means of egress, the amount of exits that we need to consider on site, the location of hacky stairs, what do we need to consider as well for the external fire spread, because we are not only worried about like a fire on our construction site, we are also worried about the neighboring buildings. And what we want to avoid is the fire from spreading to them. And then the last document that is specific for a timber structure is the STA 16 Steps to Fire Safety that was developed by the Structural Timber Association. So it's just divided like 3 different parts, but it's going to give us a little bit of information about, well, design and tender stage, fire risk again, assess fire risk, considerations, legal requirements. Then we move to the next stage that is pre-construction, and it works about legal requirements, setting who is going to be the fire safety coordinator, the fire marshals, of course, the communication between all the stakeholders. And then finally, in the construction is everything related with promoting a fire safe environment by following the construction fire safety strategy that was developed. And then we go with the case study.
Yes, so now we're looking at one of the projects that is currently kind of post-tender, pre-construction. It's a building in London, 11-story office building, so pretty high rise for CLT, timber, structural timber. We do have concrete cores, and then most of the structure, basically from ground upwards, is a timber frame structure that will eventually be protected by your cement board. So we see here an excerpt of how that will look towards the end of the building. As I said, at the beginning of the talk, we do have that challenge in the construction period about our timber being unprotected. And the cement board that I just mentioned that will be part of the fire protection measure once the building is constructed is not yet protected, not yet provided, hence the timber is being is unprotected. So from our point of view, we see that as an enormous risk and want to make sure that that cement boarding goes on as soon as possible, essentially, because we have that fire load, we need to mitigate that. The problem, though, is that in the meantime, while that board is installed, we like to keep the facade open to prevent the fire from spreading within our construction site, but instead venting out of the construction site, right? In that installation period. However, the problem, as you all know, is that if the timber is open to the outside, it will be wet, it will be exposed to the elements, which is not a good idea then to install a cement board on top of, which means that we're back around in that cycle that I was just discussing, which is obviously not particularly great. So for this project, in the design and tender stage now, we were proposing, as I said before, a careful look at the construction process and plan ahead of time, ahead of the beginning of the construction, of when we're going to place certain features. So for this one specifically, we looked at reduction of risk and ignition sources. As we explained previously, for example, we had a careful look at the compartmentation strategy, when to place certain compartment lines and provide additional temporary compartment lines. We provided 2 means of escape from the building at all times, as well as a lot of training information is currently being provided to the contractor and to the contracting staff to make sure that they're all aware of those special risks. So this is how it currently looks like for design and tender stage, the application of these 16 steps of the STA, essentially. It's a little bit small for you guys to see, so I'll just give you one example here about security. So for example, the guidance would say, like, you need to provide security to your site to prevent arson. Yeah, that's all fine and good. We can do that, but how much? What do you want to do? And the guidance then tells us, based on risk that we have on site and based on the size of the building, we need to provide certain measures. So for example, for this fairly high-rise timber frame building, we're going to provide a CCTV that's linked to a response center, including thermal cameras to catch any hotspots, for example, left over from hot works. We're going to provide a watchman that's going to be there 24 hours. We're going to have high fencing and intruder alerts to make sure that the site is safe from arson. So that was everything. If you have any questions, hopefully we have time for that. If not, thank you so much.